Now, in this problem, it is a bipartite graph because clearly we've got no members of the first set connected with each other, but connected or related to elements of the second set. So that makes it a bipartite graph. So two sets with none in the same set connected. Now, if we have a look at this, you can see that Harry likes both the Igloo and the Frosty Boy. Now, we're signing each child an ice cream so everyone's happy. What we've got to do, we've got to look at those that perhaps only have one ice cream they particularly like. Now, in this instance, Lisa only likes Havana's, so we better just sort Lisa out first. Put a strike through those two. Now that means that Dick, who also likes Havana's, will only be happy now if he gets a Frosty Boy. Dick and the Frosty Boy are out of the equation. Now Tom either likes an Igloo or a Snow Queen. The Snow Queen Tom connection is the only one there that will work. So that means that Harry will end up with the Igloo. So in setting up this next bipartite graph, I'll put the teachers on the left and I'll put their subjects on the right hand side. Now I'm just putting these in the order in which I see them. So the English, the maths, the business studies, and looks like physics running down the right hand side. And what remains now is for me to make those connections. So it looks like Swift can teach English and maths. So I'll draw a line between the English for her and the maths. Chalk can teach English and business studies. Ms. Wise can teach maths and physics. And Mr. Longbottom, only business studies. Now, if I had to then assign teachers to classes, I've probably got to look at perhaps the person who can only teach the one thing to begin with. So, Longbottom, business studies. And I'll strike them from the scenario. Now, that means that Chalk can't get the business studies, get the English. That then means the only assignment to physics is Wise. And that means that Swift will end up with the maths class.